would like to explain the Newton's laws of motion. So before starting with the concept, let me just explain you about the force. Actually, force is push or pull, or an object which helps in changing the state of a body. There are two types of forces in mechanics. First one, contact force, and the other one, non-contact force. Starting with our topic, Newton's first law of motion. It speaks as every body tends to remain in the state of rest or motion unless an external force acts on it. First law is also known as law of equilibrium or law of inertia. So, according to mechanics, if we write, so F external is equals to 0, then acceleration is also equals to 0. This is stated in first law of motion. Moving ahead, second law states that if x external is not 0, then if x external is not 0, then force is equals to mass into acceleration, where which defines as where force is defined as the rate of change of momentum. Therefore, force is equals to mass into acceleration. Moving ahead, third law states that for every action there is an equal and opposite reaction, and force acts always in pairs, but and on different pairs. Component divide. If it's moving with distance a, so while doing component divide, the angle, if the angle is theta, to, along x-axis, it's going to be a cos theta, and along y-axis, it's like a sin theta. Free body diagram. Uh, Free body diagram is actually drawn actually drawn to show all the forces applied on the body, which makes the solving of the sums much more easier. If this is an inclined surface on which a block of mass m is laid, if we draw a free body diagram of this block m, it will be like mg, which is towards down, and and normal reaction which acts perpendicular to the contact surface. So, this is the free body diagram uh, for this block of mass m. Moving ahead, applications of the three laws studied. Starting with the applications of Newton's laws of motion. First law. With the help of first law, we can find tension in the string. Uh, I would like to explain it with an example. If this is a surface onto which a block of 2 kg is attached, and onto which a block of 5 kg is attached. Okay. So this is tension T2 and this is tension T1. After drawing the free body diagram of mass 5 kg, so the mg is equals to 5g, and where it's tension T1, where body 2 kg block would be 2g, tension 2. Okay. So after solving the sum, we're going to get tension T1 is equals to 50 newtons, and tension T2 is equals to 70 newtons. First one. Second one. Second law of motion. With the help of second law, we can find acceleration when F external is not zero. So at such times, we can put as F is equals to ma, and acceleration is equals to net F upon m. Okay, and with the help of the third law, we can solve all the gun problems that is bullet retardation and everything. So further, system. Okay, if I take an example, this is a block M2 on which a block of mass M1 is kept attached to the third block M3 and to the force F. So finding acceleration of such a figure, we can just simply consider the whole the all the three blocks as included in the same system. So therefore, M1 plus M2 plus M3 considered to if it's force. In such case, acceleration is equals to F upon M1 plus M2 plus M3. Okay. If we need to find tension in the string, so we can consider M3 as the system to find tension. So therefore, tension is equals to F minus M3 into A. Okay. Pulley system. Pulley. If we consider this pulley, this is M1, this is M2, this is tension, and this is tension. Okay, if we draw a free body diagram of this figure, we'll get uh, M1 where M1G, where this is tension T, this is for M2, this is M2G, and this is tension. To draw a pulley diagram of this will be tension T, and upwards it will be 2T. Okay. In this case, acceleration, the main important conclusion here will be acceleration is equal to gravity G in bracket M1 plus M2 upon M1 plus M2, and tension will be 2G M1 M2 plus upon M1 upon M2. Okay. And we are for this tension minus mg is equals to ma, that is force, and we are mg minus is inclined plane. If we consider this an inclined surface on which a block of mass m is kept, doing this is uh, mg, which acts towards downward. If we component divide this bar, it will be mg cos theta, and this side it will be mg sin theta. And perpendicular to it, it will be perpendicular to the surface of contact with Newton's normal reaction. So therefore, over here, acceleration is equals to g sin theta. F external is equals to mg sin theta, which is equals to ma and mg sin theta. Mm cancel. If acceleration is equals to g sin theta. Okay. In the same concept, concept inclination. So if we consider this is weight and a ball is passing through and changes the direction over here. So in this case, acceleration is equals to g sin theta into cos theta, This angle is theta. So yeah, pulley trick. And if we consider this pulley, if this is V1, it's moving in V1 direction, and this is V2. This is at the center, VC. In this, we can this pulley formula, which is VC is equals to V1 plus V2 upon 2, is only valid when all the velocities are in same direction. Constant motion part 1. In constant motion, which is also known as restricted motion, if pulley is moving in, if pulley moves x, then the string released is 2x. Just understand it with an example. The pulley attached M2, M1. Okay. So if this moves with if this moves down with 2v, then this will be go up. This will be going up with velocity v. So if the pulley moves with 2v, therefore the string release will be v. Proceeding further, heavy rod. Uh, Heavy rod means which contains mass. String which contains mass. If we consider this heavy rod block attached, and then this is A, B is at the center, and this is C. So after deriving, tension at point A is equals to mg. Tension at point B is equals to capital M plus m by 2. It will be m by 2 because it's at the midpoint, it's like half. So, and then this is in the d3. And this will be tension at point C will be m plus small m, which is g. So after concluding, I would like to conclude tension at TC will be greater than tension at B and tension at A. Let us understand the concept of Lewis theorem. Okay. There are these three forces after moving. Lewis theorem states that if we consider this point A, this point B, and point C, uh, F opposite force opposite force opposite will be like F1 upon sine theta, F2 upon sine B, and F3 upon sine C. This is an important conclusion derived from here. Let's understand mass versus weight. Okay. Considering three situations, elevator, the man standing there. Okay. In this elevator isn't moving, so therefore normal reaction which is put downwards will be normal reaction will be mg. In this case, the elevator is moving upwards with acceleration a. Therefore, normal reaction will be m in bracket g plus uh, plus acceleration. And in this case, the elevator is moving down with acceleration a. Therefore, normal reaction will be m and g minus a. In this case, the weight of person will weigh more in the second case. So proceeding further, understand the difference between a spring and a spring. Okay. Spring only has a pulling force, whereas spring has both pull and push force. String only transmits force, whereas it stores and transmits force both. Moving ahead with spring force. Uh, According to formula, Fs is equals to K into delta x. Delta x is considered to be the change in uh, compressions and extensions, and K is considered to be the spring constant. So, uh, yeah, if we just take an example, this spring which has been pulled from the side x1 and x2. So therefore, spring force will be K in bracket x1 plus x2. Consider another example. The spring attached to a mass block of mass. This is mg. F is equal to this is K in bracket x. So if we consider delta x, therefore mg upon k. For example, so this is block mass 3m, mg acting towards downwards. So delta t is equals to 3 mg upon k. So combinations of string. Combinations. If the springs are arranged parallelly, uh, that is one below the other, the mass common force is. So K equivalent will be K1 plus K2. And if we consider it in theory, which is attached one side besides each other, mass M, this is force. So K equivalent is inversely proportional equals to 1 by K equivalent is equals to 1 by K1 plus 1 by K2. Important conclusion here is spring constant varies inversely with the length of the spring. Okay. Frame of reference. Okay. Basically, frame of reference is from the point from where the object. हाँ.
एक चीज बताओ कि ये पैरेलल कॉम्बिनेशन में कांस्टेंट क्या होता है, एक्स या फिर एफ?
X. F, sorry.
श्रावणी,
हाँ.
पैरेलल कॉम्बिनेशन में स्प्रिंग का जब दोनों पैरेलल कॉम्बिनेशन होते हैं उस टाइम पे कांस्टेंट क्या होता है, फोर्स कांस्टेंट या फिर एक्स कांस्टेंट होता है?
Force constant.
और सीरीज कनेक्शन में
X constant.
पक्का?
हाँ।
गलत नहीं बोल रहे हो आप?
तो आप कितना कंफ्यूज करते हो?
अच्छा, डिराइव कर सकते हो आप फॉर्मूला? के इक्विवेलेंट इक्वल टू के वन प्लस के टू।
तो देखना पड़ेगा।
आप गलत बोल रहे थे। पैरेलल में एक्स कांस्टेंट होता है, पैरेलल में फोर्स कांस्टेंट नहीं होता है।
And from where the object is being seen. So there are two types of frame of references. First one, inertial and non-inertial. So inertial frame of reference means like the observer is at rest or is moving with constant velocity. We consider road, car is moving with constant velocity, and an observer uh, standing beside, which is at rest. This is known as inertial frame of reference. Whereas in non-inertial frame of reference, observer is not at rest, and so the assumptions made by the observer are not correct. We consider this as an elevator in which a block of mass m is placed, and the observer standing, it's moving with acceleration a. It's an elevator. Okay, so over here, tension is equals to mg plus ma. Um, uh, from this, we derive a new concept of pseudo force. Pseudo force is also known as frictional force, which actually doesn't extend in the it does not extend, but is considered to make it more simple. So, pseudo force plus non-inertial frame is equals to inertial frame. So, if we consider pseudo force is equals to Pf Pf, which is equals to mass into acceleration, and we need to remember that it always acts in the opposite direction to the acceleration of the frame. Therefore, if we consider this elevator, so this is the block mass m. This is acceleration moving upwards, mg. So therefore, pseudo force is applied over here. Therefore, tension is equals to mg plus ma. Uh, Moving ahead, constant motion. Coming up to the last concept, there are three concepts based on this. If we consider this big block, which is over here, and to which a pulley is attached, and this is a block of mass m attached. If in the first case, if the block is moving with velocity, if the block is moving with velocity v, then the velocity of vb, that is the velocity of block, will be simply v. If we consider the second case in which big block is moving and the mass of the block isn't moving, so this big block is moving with velocity v, and this is mass, and this is attached. So in this case, if we try to find the velocity, it will be in somewhat this direction. But the velocity will also be there in the x direction due to the velocity of the block. So if we draw this, so will be velocity with, and over here this on the x-axis, and over here if we try to find the velocity v net, which equals to v net will be under root of t 2v. Okay, considering third situation, in which both the block and the pulley is moving together. Uh, in this case, if we draw a diagram, okay, the V, and this will be due to the block. This V will move due to the block, and this due to the string. So therefore, so it will be 2V. If we find the V net, therefore V net is equals to under root of 5V. Going up to our last concept, impulse. Impulses is equals to delta P into F into delta T, which is delta T is change in momentum, and this is area under force time graph. With this, I end up my lecture. Arranged. So here I'd put on the camera and over here the book down. So this was my setup.